Hello, back again for the third type of mirror. So we've done curved mirrors, concave with a real image. We've done concave with a virtual image behind the mirror. And we have our third type of mirror today. And this is a convex mirror. So the concave mirrors, that's like looking at yourself in the bowl of a spoon. So now we want to do, well, if you flip your spoon over and look at the back side of your spoon, you see yourself. And that's the kind of mirror we're talking about now. So this is a convex mirror. We're going to find out if it does a virtual image or a real image. We are going to start it off just as we've done before. We need a horizontal axis. Oh, look at me. I'm being smart and lowering it so it's not an eye level. We need a vertical axis. Let's make it over here. Alright, so there's our vertical axis. And this is a convex mirror, so I'm just going to remind myself that it looks like this. This is the mirrored side, so this is the back side of the spoon. If you think about this, where is the focal point going to be for this mirror? The focal point is halfway between the mirror and the center of curvature. Well, if this is a circle, the center of curvature is here. That means the focal point is going to be back here. So a convex mirror has the focal behind the mirror, because that's where the center of curvature is. Center of curvature is out here. So I'm going to have a focal point behind the mirror. And I'm going to double it to get my center of curvature. Oh, that was awful. I'm going to make something with a better number. Okay, let's do 15 and 30. There we go. So there's my center curvature. There's my focal. Good. Convex. Axes. What else do we need? Oh, that's looking good. Okay, so now we're going to put an object in front of the mirror. And again, this is the mirrored side. So the object is going to be out here somewhere. Same three rays. Okay, keep that in mind. All three types of mirrors, we do the same three rays. We just have to think about kind of the order of what they mean. Our first ray was going from the object parallel to the axis, and then with a convex mirror, it went through the focal. All right, so this is a curved mirror in this way. Okay, if I pretend this is a little flat surface of mirror, I would expect this ray to be heading off there somewhere. These rays are going to spread out because of the shape of this mirror. All right, so what am I going to do to get this ray to go up that way? Well, we know it has to go through the focal. So, okay, it's actually not that bad. I'm just going to send it through the focal. Oh boy. Okay. There we go. So it comes in, and when it hits the mirror, it goes off like this, and it goes off in a line with the focal. So that really is the same first ray. The second ray that we had went through the focal and then out parallel. Same thing here. It doesn't matter that the mirror's in a different place. I'm going to line up the object and the focal. Oh, close enough. But in this case, if you want to continue drawing it there, you can. As soon as it hits the mirror, it's going to bounce back off approximately parallel. I don't think this one's going to be as pretty as the others. So this one leaves the mirror parallel to the axis. And then we had our third ray, which is through the center curvature. Line those two up. Alright, so object to the center curvature, and then it goes out like that. Okay, so here are the three rays that are leaving the mirror. Boom, boom, boom. They don't meet back here. They're going to meet over here somewhere. So this means we have a virtual image again. Convex mirror, the focal is going to be behind the mirror, and it's always going to be a virtual image. You can't get a real image from a convex mirror. So where is it? Well, okay, again, I'm going to take these 3 rays and backtrace them. So if you want, you can do some erasing. The C ray, that's still good, but this one is going to be here. Kind of just make it very faint. How about that? So I want to backtrace the 3 rays that leave the mirror. Again, it's always the 3 that leave the mirror. I have 1, 2, 3, 4, 5 rays. You got to backtrace the right ones. So the center curvature ray is still fine because that one goes, yep, right there. I need to backtrace this blue one. Again, when I backtrace, I do dotted line to remind myself that the light ray isn't actually going there. So we've got this. Okay, so there's my backtraced ray going through the focal, and then this one I need to backtrace. Oh, look at that. I already had it. Ta-da! Didn't I? Yep. And ta-da! Look, they match up. Perfect. So our image is going to be formed right here. And because it's behind the mirror, the light rays don't actually exist here. It is a virtual image. We can do our usual measurements. So let's just say, okay, it's always virtual. In this case, it's smaller than the original object, so it's got a lot shorter, and it's upright. So that'll help us figure out if we get our magnification right. We can make our measurements, so let's do those measurements. DO, object distance, is going to be from here to the mirror 36 centimeters. And that's this distance right here, DO. My image distance is from the image to the mirror. So DI is from here to here. 15, no, sorry. There, 10. It's going to be 10 centimeters, but remember, it's behind the mirror. It doesn't actually exist there. That means we have negative, because it's kind of on the negative side of the mirror. And my focal, I had set at 15. And again, if this was negative because it's behind the mirror, this is negative because it's behind the mirror too. So a convex mirror has the focal behind the mirror, which means it's a negative focal length. If you forget that negative, your math will be all wrong, and you'll say, what's going on? And hopefully you'll stop and say, oh wait, yeah, it's behind the mirror. So F has to be negative and DI has to be negative. So you can use this and come up with your calculated image distance, and it should be close to -10. Then we can use DI and DO to come up with our magnification factor. And now magnification, it's smaller and upright. So I'm guessing it's going to be less than 1, and it's going to be positive. This tells me magnification positive. This tells me less than 1. Okay, so get DI, get our magnification, and then you can get your calculated HI once I show you once I calculate what the object height is. So that's the other thing we need. HO is going to be the height of the object, and that is 14 centimeters, it looks like. All right, so the process for the numbers, use DO and F. Those two will get you DI. Once you have your DI, you use DI and DO to get your magnification. Once you have your magnification, you can use M, the magnification factor, and the height of the object to get the height of the image. And then the height of the image, let's see what my measured is. HI, my measured image height is tiny, 4 centimeters. And upright, so positive. So when you calculate your HI, you should get something close to +4. Okay, so that is a convex mirror, where we're looking at the back side of a spoon. And it's always going to be a virtual image, so the image is always going to be back here. It's always going to be smaller and upright. So this is always true for convex mirrors. They're kind of easier than concave, because concave, sometimes it's real, sometimes it's virtual. Convex, there's only one. There's only one. It's always virtual, always smaller, always upright. And then you can do the math. Double check that the ray tracing looks pretty good. Hopefully it works, because I don't have my calculator. And then that's how we roll with convex mirrors. All right, nice job.